Hello everyone, welcome to chemistry. We are doing chemical reactions 1 and a topic known as stoichiometry. So let's move on. Let's continue where we stopped last time. Remember, last time we were balancing chemical equations. We were explaining some tactics which should be used when it comes to balancing chemical equations. Now, so this is our outline. As I've already said, this outline is based on our new syllabus. So we started with balancing chemical equations. Then today we are going to look at relative formula mass up to the end of this chemical reactions 1, which is percent yield. Now, before looking at relative formula mass, first of all, let us look at chemical formula of compounds by first defining what chemical formula is. So, chemical formula is an expression that shows the elements in a compound and the relative proportions of those elements. So, chemical formula does two things, showing elements in a compound and also showing the relative proportions of those elements. So, for example, we have water. Water is composed of hydrogen and oxygen. So, the chemical formula of water, inside the chemical formula, there is that composition showing the elements. So, we have hydrogen and oxygen. But apart from that, it also shows the relative proportions of those elements. So, the proportions of hydrogen and oxygen is in 2 to 1 ratio. So the chemical formula of water is H2O. So you can see that inside this formula there's those elements, hydrogen and oxygen, and there's also that proportion among those elements, like hydrogen having 2 atoms and oxygen having 1 atom, so ratio of 2 to 1. So let us also look at another example of sulfuric acid. So sulfuric acid is also composed of elements of hydrogen, sulfur, and oxygen. So the chemical formula of sulfuric acid is H2SO4. So as you can see in that formula, that formula also shows the elements which are present in that sulfuric acid, and it also shows the ratio of hydrogen, sulfur, and oxygen. Now here are the types of chemical formula. So there are 3 types of chemical formula, namely empirical formula, molecular formula, and also structural formula. So these types of chemical formula, we are going to discuss them later in next lessons. So for now, just know that we have 3 types of chemical formula: empirical formula, molecular formula, and the structural. But before going into details on how to write a correct formula, we need to define some terminologies commonly used in a chemical formula. So one of the terminologies used is valence. Valence is defined in different ways, but here with us we have only 2. We have defined valence in 2 ways. So valence is defined as a number of electrons that an atom of element or a unit of radical loses, gains, or shares during chemical combination. So the number that atom of element or the unit of radical loses or gains or shares during chemical reaction or chemical combination, that number of electrons is known as valence. Valence can also be defined as a measure of its combining power with other atoms when it forms forms chemical compounds or molecules. So in some books they just say is a measure of combining power of element or compounds. So valence is defined as a measure of its combining power with other atoms when it forms chemical compounds or molecules. Now, let us continue looking at terminologies used in chemical formula by looking at radical. So, radical is defined as an atom or group of atoms that has at least one unpaired electron. So, these radicals can either be positively charged or negatively charged. So, the presence of unpaired electron makes the radicals to become unstable and highly reactive. So the presence of these unpaired electrons or unpaired electron makes the radical to be unstable and highly reactive. Another terminology used is also known as cation. So what are cations? So cations are positively charged particles. So atoms or group of atoms that are positively charged are known as cations. So these cations they attain that state by losing electron or by losing electrons. So they attain positively charged by losing electron. For example, we can have that element X. So you see that element X has both positive and negative. One positive and negative, or one proton and one electron. So proton for positively charged and electron for negatively charged. So that element is in stable form. Is same as element which can be found on periodic table with no charge. So for that element to become cation, it means it needs to lose an electron. So after losing an electron, you see that element now has become a positively charged. Now let us look at another terminology which is known as anion. An anion. So let us look at another terminology known as anions. So these anions, they are negatively charged particles. So the negatively charged particles, they attain in that form by gaining an electron. So these are some of terminologies used in a chemical formula. So let us look at the final terminology used in a chemical. Now let us look at this last terminology used in a chemical formula. So this terminology is known as polyatomic ion. So polyatomic ion is defined as an ion composed of more than one atom. An ion composed of more than one atom. For example, the ammonium ion is one of the examples of polyatomic ion. So ammonium ion consists of one nitrogen atom and 4 hydrogen atoms. So it's an ion composed of more than one atom. So you can see ammonium ion composed of more than one atom. So together they comprise of a single unit or a single ion. So the combination of those atoms, they form a single ion, which is known as polyatomic ion, having more than one atom. So this polyatomic ion has a single charge. For example, ammonium has a positive charge. So that one is also known as cation because it is positively charged. But it is also known as a polyatomic ion just because it consists of more than one atom. Now let us look at common valences of elements and compounds. I hope by now you know what a valence is. So let us see the common valences of elements and compounds. But before that, let us know that valence electrons brings the knowledge of radicals. Valence electrons brings the knowledge of radicals. So that one will be explained clearly. Then radicals are important in writing compound formula. So we are saying that valence electrons brings the knowledge of radicals. So after having that knowledge, then it is when you can write your compound formula. For example, we have general valences of elements. General valences of elements. We have general valence of compounds and also have general valence of elements. Example, valences of elements in a periodic table. So we have different elements in the periodic table, and we also have different valences in that periodic table. So let us look at this table. The first row composed of groups. So we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. So in a periodic table, a general periodic table, we have 8 groups. And another row we have valence, which says group 1 has a valence of 1, 2 for group 2 up to 8, which is 0 for has no valence, and also have charge on ion. Also have group 1 with positive charge. So let me explain in this way. You can know the valences of elements by first of all knowing the formula in which that the group in which that element is found. For example, if the element is found in group 1, it means its valence is 1. So in terms of charge, its charge is +1. So most of students confuse between valence and the charge of an element or an ion. For example, instead of writing the valence, they write the charge. For example, you can be asked to write the valence of lithium ion. So lithium ion, its valence is 1, while the charge of that lithium ion is +1. So don't write +1 to mean the valence. So valence has no charge. Now let us go to valences and in different groups. From different 1 up to from group 1 up to group 4, the number of electrons in the outermost shell equals the valence. The number in the outermost shell, the number of electrons in the outermost shell is equal to the valence. The number of electrons in the outermost shell or in the last shell is equal to the valence. For example, I know aluminium. Aluminium is in the group 3, and aluminium has 3 electrons in the outermost shell. So it means that that aluminium has a valence of 3, while it also has a charge of +3. So from group 1 up to group 4, the number of electrons in the outermost shell represent the valence. From group 5 up to group 7, the number of electrons that element needs to gain in order to attain the group 8 configuration, that number is known is our valence. I repeat, from group 5 up to group 7, the number of electrons to be gained is equal to the valence. The number of electrons to be gained is equal to valence. So from group 5 to group 7, the number of electrons to be gained is equal to valence. So from group 1 to group 4, the number of electrons in the outermost shell equals the Now let us continue looking at common valences of elements and compounds by looking at elements with multiple valences. So there are some elements that display 2 or 3 values. So you see some elements having 2 or 3 values without considering in which group they are. So these elements include carbon, lead, iron, copper, and you see sulfur having a valence of 2, sometimes having a valence of 4, and also a valence of 6. So there are some elements which have multiple values. Now let us look at the valences of radicals. By now, I hope you still remember the definition of radical. It said radical is atom or group of atoms that has at least one unpaired electrons. So here the also important part, which I have already said, that the valence electrons bring the knowledge of radicals. We are going to explain that one in this slide. So let us look at different valences of different radicals. So we have a column of radical, a charge or on ion, and the valence. So you see ammonium having a valence of 1 while a charge of positive 1. And you also have, you see nitrate there having a valence of 1, a charge of negative 1, and you also see carbonate having a charge of negative 2 and a valence of 2. So I said it already that valence electrons brings the knowledge of radicals. So without memorizing all the radicals we have, you can work out the radical, you can work out the valence of a radical. For example, let's take ammonia. So you see ammonium has a valence of 1. So how can we work out the ammonium? So the ammonium is having 2 elements, nitrogen and hydrogen. So we can work out the individual valences. For example, nitrogen has a valence of negative 3. It is in the group 5. Group 5. So it has a valence of negative 3. So hydrogen has a valence of positive 1. So we have almost 4 hydrogen atoms. So the valence of 1 times 4, we are getting 4. So, and we have the valence of nitrogen, which is negative 3. So negative 3 combining with positive 4, that's when you get positive 1. So there's no need just to memorize everything. You can still work out some valence of different radicals. Now this marks the end of today's lesson. So in the next lesson, we are going to look at how to write chemical formula, which is the most part, which makes this stoichiometry to be one of the toughest topic in MCE level. And we are going also to look at relative formula mass, how to calculate relative formula mass. So thank you.